Welcome to another video. In today's lesson, we'll be learning about Newton's third law of motion. And you should be familiar by now by Newton's first law, second law. If you're not, make sure that you take a look at our previous releases, which are targeting these main concepts, because they are quite interlinked with each other. When it comes to describing motion, every single physics student, engineering student, mainly everyone should be familiar with the concept of Newton's laws of motion, the first, the second, and the third law. And in today's lesson, we'll be tackling Newton's third law of motion. So in this lesson, we're going to explore Newton's third law of motion. Now, in the previous lessons, we've taken a look at Newton's first law and second law, where we said the first law states that an object at rest or moving with a constant velocity will remain in its current state unless acted on by unbalanced force. The second law shows the relationship that we have between the force and the mass and the acceleration, represented by the formula F equals to ma. And now we're ready to transition to Newton's third law of motion, which states that for every action, there is a reaction equal in magnitude, the opposite in direction. So we have to highlight the important terms right here. Equal in magnitude, opposite in direction. What does that mean? So if you apply a force, let's say you are standing in front of a wall, and then you're going to be pushing the wall. This is your hand, and you're going to be pushing the wall with 10 newtons. The wall is going to be pushing you back with 10 newtons. So for every action, which is pushing the wall with 10 newtons in this case, there is a reaction, which is the wall pushing you back, which is equal in magnitude. Both of them, they have 10 newtons, but the direction is opposite. Let's have another example to clarify the concept. Let's say you are sitting on a chair. This is a chair, and a person is sitting on the chair. Let's say whatever person it is. Here we go. Now, the weight of the person will apply a force, which is the force of gravity, which is the weight. It will push against the chair, correct? The earth will be pulling the person downwards, and this force will be pushing against the chair. So what will happen in this case, the chair is going to react with the same equivalent force, which is the normal force in this case, to cancel the weight. Let's say the weight is 10 newtons, the chair will be pushing back with 20 newtons, the chair will be pushing back with 20 newtons. However, the direction is opposite. So this is mainly Newton's third law of motion, where we have for every single action, the application of a force, you're going to be having a reaction which is equal in that effect, equal in magnitude in the quantity that you have, but the direction will be reversed. A great example would be if you do have a rocket, and let's say this rocket is in space, and what's going to be happening is, this is one of the key principles that it's used in the launching of the satellites or rocket into space, because as we know, in space you do have vacuum, and vacuum does not facilitate the movement of the objects because we don't have air resistance, and it doesn't flow through the engine. Air doesn't flow through the engines of a plane, let's say, or a rocket, to be used with the fuel injectors to be able to push and provide that thrust and just simply drive the object forward by let's say floating within a fluid, which is air or water or whatever it is. But within space, we don't have the surrounding environment to facilitate the process, and you can see the effect on of Newton's third law of motion clearly within the space setting, where you have a rocket, let's say, and you have vacuum. and the rocket is just simply floating in space, and it needs to move now, right? Now this rocket, let's say the engine is going to be releasing some gases, and these gases are going to be pushed backwards, let's say with a force of 1,000 newtons. So the rocket is pushing the gases with a force of 1,000 newtons. So what's going to be happening in this case, the gases are going to be pushing back with a force of 1,000 newtons, but the direction is reversed, and this will cause the rocket to move forward. So by pushing the gases backwards, the rocket is able to move forward because it's applying a force of pushing the gases, let's say 1,000 newtons to the left side. And because of the third law, for every action, there is a reaction, which is the gas is pushing with an equivalent force of 1,000 newtons in the opposite direction, opposite reaction. So we have an action and a reaction. You push to the left, you'll be pushed to the right. You pull to the left, you will be pulled to the right. The magnitude is going to be the same, however, the direction is going to be reversed. And this is a key application of rockets traveling within space, because in vacuum, if an object is just simply floating in space, it will continue to do so forever, and there's no way to be able to control it without the application of the third law. You're going to be pushing in one direction, and the reaction will push you in the opposite direction. And this is the basis for movement of rockets within space. So this simply wraps up the concept of Newton's third law. For every action, there is a reaction equal in magnitude and opposite in direction.
Hope that you found the video beneficial. If you did, feel free to subscribe to our channel and stay tuned for our latest educational content that will surely transform your educational journey. Whether you are a physics student, an engineering student, or a working professional, we surely have something that you're going to be enjoying as part of the channel. And I'll see you in the next class.